And we're back, continuing on with the priority queue. In this video, Lee is going to skeleton in our class.
Right. All right. So we're going to do a little groundwork first. So I'm going to, or it's not so much groundwork. Let's clean up first. So I'm going to clean up our main. So that will get rid of that. I'm going to leave the console read key in here because otherwise I'll keep forgetting. And we're going to go over into our Solutions Explorer, and we're going to create a couple of new folders. So add new folder. This one will be, let's start off with code. Just so when we're done with this will snap into the Unity project quite nicely. And inside of there, we'll create another folder. Be kind of nice if they had a hotkey for a folder. And this one will be threading. All right, now inside of threading, and this one does have a hotkey, so I'll just use that. Control-Shift-A, going to create a new class. This class will be our priority queue. All right. Do a little bit of cleaning up, get rid of this Unity threading, and we'll just leave code there. All right, now what we're going to do in this video is we're just going to skeleton out the basics, and then we'll come back over the next several videos and fill this in piece by piece. So I want to start off with creating a public enumeration. This will be our queue priority. And as I said in the last video, we're only going to be worrying about 3 levels. So we'll have low, medium, and high. Inside of our priority queue, let's make this a public class. And we're going to make it a generic class. We're going to enforce it to be of type T class, or constrain it to a class.
So this will just make sure that our priority queue is strongly typed.
Yes.
Okay.
Now, because we're not going to be using queues, we're making a queue, but we're not going to use queues to make our queue, which is a little bit weird when you may be wondering, well, why is that? The reason why we're not going to be using queues is I want the ability that we get with lists to randomly access different elements. Another reason why we're not using linked lists. But I want to be able to access any element inside of one of the 3 different levels of priority, the low, medium, and high, and be able to find that element and remove it from that list in the event that somebody schedules something inside of the priority queue that is already there. Now, what I mean by that is if somebody were to schedule or put something in the priority queue at a low level, and then they come back and enter that same thing again, but then give it a high level priority, I don't want that element to ever exist in the queue twice. So what I'm going to be implementing is the ability to promote a lower level item to a higher level. So if that item is in the low level list, it will be removed from the low level list and placed in the high level list. Or let's say somebody put it in the medium and then re-entered it as high, it would get promoted from medium to high. Now this is I'm only adding the ability to promote, not demote. So what I don't want to happen is if for some reason one of the subsystems puts something into the queue at a high level, I don't want anything else to be able to come back and go, no, I'm going to demote that down to a low level. So if that's the case, and that is the functionality that I'm looking for, then I will want whoever put that item into the queue to actively remove it from the queue and reschedule it on its own. I don't want to have a demotion system in place because I don't want something to accidentally get demoted.
Okay.
So we won't be doing demotion per se. Now, we'll create the 3 lists to hold the information. These are going to be read-only list. Now, read-only list does not mean that we're only going to be able to read from the list. It just means that we're not going to be able to reassign the list itself. We can still change the elements inside of the list. So we'll have our low priority list. And so new list type T. Duplicate this. Our medium and our high. Now, while this is our own queue, being a priority queue, I want to still take the same functionality that people expect when you're working with a real queue. So there are certain things that as you create a queue,
Whoa.
wow, that was pretty cool of it, wasn't it?
Yeah.
Let's try that again. So queue, and actually I wanted var. Come on, you can do it.
For what, var?
Oh, hold on. Never mind. Yeah, I see what I did. All right. I'm going to create the first method, then I'll demonstrate what we're going to do. I want to be able to have a count of everything that is in our queue. So we're going to have a method or a property called count. So let's go ahead, and our count is only going to return. So for now, it's going to return my queue so I can demonstrate what's going on. All right, you're going to return 0, and then I'll put the queue above it. I'll get there, really, I will, I promise.
Well, it really has been a long day for you.
Yeah, it has. But, you know, it's all good. All right.
So when you go to, I'm just trying to make sure I'm following what you're doing here. So when you're going to return the count back, is the count everything that's in
All of the list, yes.
So you can't just take the low, medium, and high, the counts from those, and add them up?
Yeah. But that's not what I'm trying to demonstrate here.
Okay.
I am out of it, but not that far out of it.
Oh, okay.
All I wanted to demonstrate is we're just skeleting in here right now. What I want to do, though, is the methods that we're going to be skeleting in is to mimic the functionality that we get with a regular queue.
Oh, okay. I see what you're doing.
And I'm not going to even implement all of these. There are only certain ones that we're going to deal with, those being count. So we're going to implement count. I want to implement DQ, NQ. I want to implement peak. So we're going to use peak. I want to implement contains. And something that we don't have that we'll be implementing is going to be remove. So as you can see, there's no remove inside of a queue. But because we're building our queue from lists, we're going to be able to explicitly remove any item from any of the priorities. So we'll implement that functionality. So that's a deviation from a standard queue that we're going to be able to get. And I also want to implement clear.
Okay.
So, but right now, I didn't want to implement any of the functionality. I just wanted to show where I was going with this. All right, so let's go ahead and put in the skeletons for the rest of this. So we'll have enqueue. I still think enqueue is probably the weirdest word in the English language. Personal opinion, though. All right, so we're going to enqueue tf type, and we're going to get a queue priority, which is there here, and we'll call this priority. And we'll get a public dequeue, which returns type T. Our peak. Contains, which returns a bool. And takes an item of type T. Remove, again taking an item type T. And finally, we'll implement a clear. And that will be the skeleton for our method. Let me put a return type on these so we don't get any errors. All right, good. So everything builds out, no errors. So that'll wrap this video up. In the next one, we'll come back and we'll start implementing functionality into this.
Awesome. Sounds good. All right. Well, thanks a lot, everyone.